Okay. The inequality we see here be fairly easily solved. I'll do that over a little further. Rewrite it 4x minus 3 less than or equal to 9x plus 7. And everybody did valid steps on this. So there maybe is an arithmetic mistake one time and maybe a valid operation done. Other than the ones I'm going to do, okay? First thing we want to do, we want to get our x's on this side. We don't want that -3 there. So we add 3 to both sides by adding the equation 3 equals 3. And that gives us 4x less than or equal to 9x plus 10. The 3 adds to the 7, not to the 9. You can't add 3 to the 9 because the 9 is attached to that x and you don't know what the value of x is. Okay, so I'm still seeing that, but I didn't see it today. I just want to remind you though. Okay. Now we want to get the x's on one side, so we have a 9x over here. We subtract 9x from both sides. And it's an equality. Okay, 9x equals -9x equals -9x added to this inequality gives us -5x equals 10. Then we divide -5x by -5. Now, at least one person made an error here. What does this mean? This means, I'll write it over here. Make sure you understand this one way or another. I could write this as -5 over -5 times x over 1. Why is this equal to this? Because if you multiply -5 by x, you get -5x. If you multiply -5 by 1, you get -5. And then, of course, that equals 1 times x over 1. 1 times anything is that thing, and 1 divided into anything is that thing. So multiplication by 1, division by 1 doesn't change whatever you got, so you get x. As a result, we have x equals -x. Okay. Where did I start losing it? That should be less than or equal. That should be less than or equal. So x is less than or equal to -2. And then you check. If x equals -2, then we have 4 times -2 minus 3 less than or equal to 9 times -2 plus 7, which comes out to -11 less than or equal to -11. And that's true. Because, of course, the solution is x is less than or equal to -2. If x equals -2, that's in the solution step. And that should make the inequality true. And -11 is less than or equal to -11. Okay. Now we check. Let's just let x equal, I don't want to use 5 because I had that there. Let's say x is -4. Get 4 times -4 minus 3 less than or equal to 9 times -4 plus 7. It's -19 less than or equal to -36 plus 7 is -29. So there's something wrong. So now we did something wrong in solving the equation, and this is why you check. Okay, very easy to keep writing down less than or equal, but look what I did here. I divided by a negative, didn't I? If I divide by a negative, that reverses the inequality. So now the inequality should be this greater than this, and now x is greater than or equal to -2, and this shouldn't be so. Since -4 is less than -2, it's not greater than or equal to -2. Okay? And then if x equals, let's say, just use 6, we get 4 times -6 minus 3 less than or equal to 9 times -6 plus 7. That's -24, -3 is -27, less than or equal, -54 plus 7 is -47. That's true. And it should be true because if we look now at the solutions on a number line, where all that was visible, still not sure. Okay, there's my finger, there's my finger, it's close. Okay, so all I've done here in this one, let's review what I did. I got -5x over -5. I claim that's equal to x. Why? Because I can write -5x over -5 is -5 over -5 times x over 1. Why is that equal? Because -5 times x is -5x, and -5 times 1 is -5. And when you multiply fractions, you multiply numerators and you multiply denominators. -5 over 5, -5 is 1. So we have 1 times x over 1. Well, 1 times anything or 1 divided into anything gives us whatever that thing is. We end up with x. Okay, continuing with the check, x equals -4. And that's on one side of -2. And I'm going to use x equals 6, which is on another side of -2. If x is -4, we substitute into the equation. We get -19 less than or equal to -29, which is not so. This tells us that -4 shouldn't be in the solution set. This, where we substitute six, making all kinds of clerical errors here. My numbers aren't right. We substitute 6. What I wrote down there, -27 less than or equal to -47 isn't even true. It's going to be 24 minus 3, that's 21. This is 61. That's true. Okay, now if I want a picture on a number line, well, here's where x equals -2. Now, x can equal -2 or it can be greater than -2. If x equals -2, that means I'm going to draw a closed dot here. If x was just greater than -2, I draw an open dot, just a circle without filling it in. And you need to review that in open math if you're not familiar with that, but that's a pretty easy rule to understand if you do a little bit, okay? So then we take all numbers that are greater than -2. Well, that means all numbers to the right of -2. So I'll use just a little bit of different color for this. First of all, I'll make that dot as yellow as I can. Now here's your axis. This arrow just keeps going. Every point on this arrow represents a number that's greater than -2. And if you look at -4, which we substituted here, it's not in the solution set. And it wasn't, right? It didn't work. If we substitute, if we use 6, which is maybe over here somewhere, that's in the solution set. Goes right through that arrow, right? So there we have it. There's a picture of why the check is so, or a picture that represents the results that we got from checking. And here's the solution as an inequality. And that's your solution as an inequality. Here's your solution as a graph. And the solution as an interval is -2 infinity. All the numbers from -2 to infinity. The closed bracket here indicates that -2 is part of the solution set. If it was a greater than without a greater than or equal, this would be a parenthesis here. And this infinity means any number bigger than this, we can keep going as far as we want to go, and then we can keep going further. We never get there because we can always go further. We extend that arrow, okay? So infinity is something we approach, but we never reach it. So infinity is not a number, it's something we can just approach. All right. Okay, now, as I say, people are pretty good with the mechanics of solving the equations. And I saw that in the open math. And I'll put some, I didn't get a chance to put some comments in your work. I should be able to get to that before the end of the week. But there's a lot of demands on my time right now. And just a couple of monkey wrenches got thrown into things yesterday, so I'm a little behind. Okay. Okay, to this one now. Now, you didn't have an assignment on absolute value, but you have one for Friday or something like that. You know, look at the schedule. Absolute value of x equals 5. What did I do with this last time? Now, some people wrote this down, wrote the arrows down, and that's good. Don't think I saw the or in there, but the logic of this is important for reasons that you'll come to appreciate later. Okay, so you want to write or. This means x can be -5 or it can be 5. We wouldn't say and because x can't be both. If we said and, we'd say x is -5 and x equals 5. No, x equals 5 is a solution and x equals -5 is a solution. But to say an and here means that x would have to be both. It's an important distinction. Anyhow, that's your solution. That's all there is to that one. And this one isn't much more difficult. Now, we didn't do one like this, so if you didn't know what to do with this, okay, if you did, that's really great. Okay, so here, this tells us, well, if x minus 2 equals -5, is this a true statement? Well, it means you got -5 inside the absolute value sign, and the absolute value sign of, I wrote this as a less than. Some attention part of my brain isn't engaged this morning, obviously. Um, so it should be absolute value of x minus 2 equals 5. We'll look at inequalities in a few minutes, but we don't want to go there until we get the equalities down. So this tells us that x minus 2 could be -5. Again, because if x minus 2 equals -5, then this is -5, and the absolute value of -5 is 5. There's no doubt about that, no argument. You want to understand what that's saying, okay? Then we have x minus 2 equals 5. Can't be both, so it's an or, okay? Then we add 2 to both sides. And we get x equals -3 here. Or x equals 7 over here. That makes sense? And we add 2 equals 2. So our solution set this is one way of writing the solution set. Another way is to write set braces with a 7. Okay. Now, I think open math generally doesn't ask you to use set braces. It says just list them. Okay. It's one of the disadvantages of doing this thing from a keyboard. Now, we do have set braces, but for some reason, open math might have trouble recognizing set braces or something like that. Got a comment, so let's see. Maybe what I'm saying isn't even right, or maybe it could be modified. The comment was that open math does use set braces when they give you the problem. They just don't ask for it on the solution. And I think that's unfortunate, but there's probably a good technological reason for it, because the people that wrote these problems know as well as I do that it's important to put those braces in. So there's some reason they apparently can't do it. Possibly in the programming, I programmed it a little bit, but not recently, and I don't remember the details. Very simple to program. Simple enough that you can forget the details because they never really give you a lot of trouble. Okay, solution set's -3, 7. And then a picture. Here's x equals -3. Here's x equals 7. Let's make sure I can see that on the screen. And we just put a big old blob of a dot here and another one here. And there's a picture of the solution. Okay. It's important that you be able to do the picture, give the solution 3 ways. This way, or this way. Okay. All right, now we're going to go on. And I'm going to ask you to solve a problem. See what you can do with it. Let's try it this way. Greater than or equal is tougher than less than or equal, so let's go less than or equal. And I'm getting too far ahead. We're just gonna make it equal. Then we'll do inequalities. Just aiming toward inequalities, but let's get there in simple steps. And the screen is blurry, so we'll put up a picture. Should get it here. Okay, now we're wanting to solve the equation, absolute value 2x minus 5 equals 13. Well, just like, remember when we had absolute value of x equals 5, we knew that would be true if x was negative 5 or if x was equal to 5. Because understanding absolute value, you realize that x could be a negative number whose absolute value is 5, in which case it would have to be negative 5. And of course, if x is 5, you also have a solution. We know that those are the two solutions, but we write it like this. When we get to an equation like this, we do exactly the same thing. Now, we don't write negative 5 or 5 because this equation is different than this. We got 13, so whatever's inside the inequality has to be equal to 13. And I said the inequality, the absolute value signs. So whatever's in there must be equal to 13 or negative 13. Okay? So we get, for this equation, we have to split this into two equations. 2x minus 5 equals negative 13, or 2x minus 5 equals 13. Now we have two equations that we can easily solve for x, especially if we do all the steps. There's a couple people skipped a step and just did something that looked right, but it was wrong. And you know better. We write 5 equals 5. Why do we do that? So we can add it to this equation and get rid of the 5 on this side. That gives us 2x equals negative 8. Or we can add 5 equals 5 to both sides of this one, and we get 2x equals 18. Well, 2x equals negative 8. Write out all the steps. 2x divided by 2 equals negative 8 divided by 2. And that gets a little tedious if you really know what you're doing and have a lot of practice. But if you haven't, do it, because you're going to need to be in the habit. Okay? And then 2x over 2 is the same as 2 over 2 times x over 1. You can look at it that way. And you see that the 2 divides the 2, gives you 1 and all that. And this gives you x. But there's a reason it gives you x. Right over here also. Here we would have 2x over 2 equals 18 over 2, so that x equals 9. Okay, so the solution set, -4, 9. Graph, X equals -4 here, X equals 9 here, dot here, dot here. Okay? 3 ways of writing solution set as a choice of equalities is a set notation graphical. Make sense? Notice that I don't have the absolute value signs here or here. Okay, if I put the absolute value signs here and add 5 to both sides, I'm doing something invalid. Got to get this thing out of the absolute value signs before I can start solving the equation. The thing I see on a test after explaining this and after doing it and after seeing everybody do it right, 70% of the people will simply remove the absolute value signs and solve the equation they get. So they get this equation and they get this solution, but they never do this. You don't split it into 2 equations. Understand logically why you do that? Or just really get in the habit of doing that so you never forget. If you understand why you need to do it, it's easier to remember. But sometimes you just got to keep doing it, and then it slowly dawns on you why you're doing it. And I'm trying to emphasize both here. All right. Now I want to go to an inequality. And simplest inequality. I want you to remember this. But now inequality. Yeah. Since we just started our study of inequalities with x equals 5, right? Absolute value of x less than 5. Now it's an inequality. And I'm going to write actually less than or equal in this case. So in the first place, this is true if x is equal to -5 or 5, right? Because it's less than or equal. Okay. Can everybody give me a number with their fingers that makes this true? Okay, 5 makes it true. We're sure about that. Number other than 5. 0, does 0 make it true? Is absolute value 0 less than or equal to 5? Yeah, 0 is less than 5. So it's certainly less than or equal to 5, right? The absolute value of 0 is 0. Now, 2, okay? Is absolute value of 2 is 2. Is that less than or equal to 5? Sure is. Or 3, or 4, or 1, or pi, 3.1415926. Okay? Make sense? A way big bunch of numbers between 0 and 5. Okay? Can anybody give me a negative number that makes it true? Can everybody give me a negative number that makes it true? Okay? Okay. I get 3, 5, 4, 2. Okay? -3, -5, -4, -2. Pretty clearly. But the integers would be -1, -2, -3, -4, and -5, right? For any of those integers, this would be true. Well, that's a justification, at least an intuitive justification for saying, okay, so that means that, first of all, x has to be less than 5, right? Not less than or equal to 5. Because it isn't true if x equals 6 or 5.00001. Anything bigger than 5, no way. Okay. However, There are a lot of numbers less than or equal to 5 that don't fit that, like negative 1,000. Okay? Any negative number past negative 5 isn't going to solve the equation. So we got to say, and x also has to be greater than or equal to negative 5. Okay? We go from 5 down to 0, and all those numbers work. We can go then all the way down to negative 5, and the numbers work, but past negative 5, they don't work. Another way to do this is complete agreement with this, and we're going to see how it moves. Okay. Here's where x equals negative 5. Here's where x equals 5. And you notice that x equals 0 is right in the middle. We don't really need that, but there's something important about that, so I'm going to write it there. Okay? And this says, just from what we figured out, by figuring out numbers that make it true and false, like for integers, x could be negative 5 or negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, right? Those are the integers and all the numbers between those integers. So x could be negative 5, x could be 5, and x could be anything in between. There's our solution set. And we can reason that out very easily. It's a very simple inequality. We can understand why that's true. Just think, what are some numbers that make it true? Where do those numbers stop making it true? Okay. We can go up to 5, but no further. Is any further than 5? The absolute value is going to be bigger than 5. To the left, we can go out to negative 5, but we can't go any further because then the absolute value of the number would be greater than 5 again. Okay. Let's take this again. X less than or equal to 5. In interval notation, x less than or equal to 5 means the interval negative infinity 5. So x has to be in the interval between negative infinity and 5. It has to be somewhere from 5 on to negative infinity. But it also has to be greater than or equal to negative 5. And x greater than or equal to negative 5 is the interval negative 5 infinity. Okay, so this is what we get when we split the thing. This is what I claim we get when we split the thing. This is what we get intuitively, and we're pretty sure of it just by thinking of what numbers work. This is the interval notation for this, because x less than or equal to 5 means x is in the interval from negative infinity to 5. And x greater than or equal to negative 5 means that x is in the interval from negative 5 to infinity. That and in set notation is written as an intersection. That's called an intersection symbol. It's not all that difficult to understand. It's just another weird symbol. And some of you have probably seen it. It means here are two sets. Uh-oh. You see the mistake I made? This is a less than or equal. These are less than or equal. I needed a square bracket on the end there, right? Okay. And I need square brackets here. Otherwise, 5 and -5 wouldn't be included. Okay, back to what I was saying now. How to be in this set and in this set. Okay, and this says the same thing. You can interpret this as and in the sense that X has to be in here and it has to be in here. Well, we can draw those two intervals. Okay, the interval -∞5 ends at 5. But it's everything less than 5, isn't it? So this is the interval -∞5. And then we have the interval from 5 to infinity. All the numbers are from -5 to infinity. Okay, so that would be all the numbers from here to infinity. There's the interval -5 infinity. And, I keep using, I don't know why I'm doing this, but I keep using parentheses where I need to use square brackets. Doing it because apparently don't have enough attention right now to pay attention to everything. Sometimes we have those days. Okay, so I apologize for that, but there it is. And it's now correct. Well, it's got to be in this, and it's got to be in this. So let's just say we want, got the wrong color. We want to ask if, what's that? That's maybe X equals -9. Is X equals -9 a solution? Obviously not. The absolute value of -9 is 9, and it's not less than or equal to 5. Is X equals -9 in this set? This is the set that's in yellow. Is X equals -9 in that set? Well, sure, X equals -9 is here, right there it is. It's in the yellow. Is X equals -9 in the orange? No, it's got to be in both. Okay, so X equals -9. Is not in, I better just write the words, not in the solution set because it's only in this part of the set, not this. It's got to be in this part and in this part. That's the test. I give you a number, you see if it's in here, and then you see if it's in here. And if your answer isn't yes both times, it's out. Okay, let's try X equals 2. Is X equals 2 in the set -∞5? Yeah, that's less than 5, isn't it? And it's in the yellow. Is X equals 2 in the set -5 infinity? Well, -5 infinity is 2 between -5 and infinity. If you start at -5 and go to infinity, you pass 2. You sure do. I mean, here's -5. You're going to infinity. There's 2. Okay? And -2 is in both the yellow and the orange set. Okay? So we can say that the numbers that are in both sets start here. because if it's to the left of here, it's only in the yellow set. And they end here. Because if it's to the right of here, it's not in the yellow set, okay? If it's left of here, it's not in the orange set. If it's to the right of here, it's not in the yellow set. And you can see it in the picture. Where do these two overlap? Well, if you have studied sets at all, you know that an intersection is where the two sets overlap. Okay? And if you haven't seen the picture, the Venn diagram, you can ignore this, but if this is a set A and this is a set B, then the overlap is the intersection. If it's in both sets, then it's in here, and if it's in here, then it's in both sets. Have you seen that picture? How many of you seen that picture? Okay. You show that picture to an 8-year-old, they won't really understand. The brain isn't, in most 8-year-olds, it isn't developed enough to understand all the implications. Starting about 12, it is. Well, you can't show everybody everything there is to show them, so decisions get made. It depends what course track you're on and stuff like that. But certainly by Algebra 1, or definitely by geometry, let's see that. If it's helpful, fine. If it's not helpful, ignore it. Okay. So by the same token, see if you can solve this one. Oh yeah, one thing I didn't do here, I'm going to draw those lines. Get those lines and get the and. So we see that we're dividing this into two columns, and then we reason out what goes in the column. Okay. Now, if 2x plus 3 is less than or equal, if absolute value of 2x plus 3 is less than or equal to 19, think about numbers again. Now, the numbers are too big. Most of you don't have 20 fingers, and nobody has more than 20. I'm pretty sure I've counted them all. Yeah, I've seen your hands, mostly in the form of a fist. So you gotta, keep it down. But yeah, seriously, think about numbers that make this true or not. If the thing in the inequality is bigger than 19, do you have a solution? Can't be. If this number is bigger than 19, then its absolute value sign is bigger than 19. It can't be bigger than 19. Well, this tells us that, first of all, 2x plus 3 is less than or equal to 19. Because if it was bigger than 19, this would be false. And it's got to be greater than or equal to negative 19. Okay? Because if it was less than negative 19, that would be like negative 20. If what's in parentheses or in the absolute value signs is equal to negative 20, the absolute value wouldn't be less than or equal to negative 19. Another aid might be this. x minus 3 must be in this interval from negative 19 19. Does that make sense? To be less than or equal to 19 can't be less than negative 19, can't be greater than 19. Okay? So this tells us just that. 2x plus 3 has to be less than or equal to 19. So that 2x, it's 2x plus 3, has to be on this side of 19. And it also has to be on this side of 19, negative 19. That gives you this inequality. Inequalities go two different ways. Okay, so we can solve. And I'm just going to write it down. And we find that x is less than or equal to 8. This inequality, now I'm getting things messed up all over the board. You get x greater than or equal to negative 11. Now that's all messed up, so I'm going to erase this Venn diagram. Use a little room here. So that your solution set turns out to be negative 11, 8. Like this. And, you know, gotta have a bigger monitor over there so I can see what I'm writing. Better talk through it once more. This is less than or equal to 19. First of all, if what's inside is less than or equal to 19, what's inside is this. Okay. What's inside also has to be greater than or equal to negative 19, because if it's less than negative 19, it's out here. So I've done this. 2x plus 3 must be in this interval between negative 19 and 19. On this side of the interval, the absolute value of 2x plus 3 would be greater than 19. And on this side, the absolute value of 2x plus 3 would be greater than negative 19. So we split this into the two inequalities. Okay, that gives us this inequality, this inequality. We just turn the crank and solve them. We get x less than or equal to 8. So that would be everything to the left of 8. But also x has to be greater than or equal to negative 11. So everything on this side of negative 11. If I had room, I'd write x less than or equal to 8. And I'm going to write it x less than or equal to 8. And greater than or equal to negative 11. One more thing we haven't looked at. absolute value of X greater than 5. We've only got a couple of minutes, so I'm going to just say this, and then you can let open math make it clearer to you. This means certainly true if X is greater than 5, or X can be less than -5. So here we have -5, we have 5. The solution set is between -5 and 5. To the left of -5, we get numbers whose absolute value is up. Sorry. Here's -5. Here's 5. Here's values of X that are greater than 5. Here's values of X that are less than -5. Can't say and, because it can't be here and here at the same time, right? It can't be on this arrow if it's on this arrow and vice versa. So there's an or in that case. So when you have an inequality greater than a number, you get this or. And you get a split definition. So I'd like to have time to write all that out in detail. But if you think about the detail that we've gone into and everything so far, it shouldn't be difficult to understand where this goes. If you have absolute value 4x minus 7 greater than 12, you would split that into 4x minus 7 greater than 12, because certainly 4x minus 7 is what's in here. If it's bigger than 12, it's part of your solution. But also 4x minus 7 could be less than -12. Okay? It could be -13. And then it would still be true because the absolute value would be 13, be greater than 12. But there's an or in here, and this is why I'm emphasizing the ors and the ands with absolute value equalities and absolute value inequalities. It's a little confusing, but it's worth sorting out, because if you sort it out, then you really understand it. Okay, now you have 2 assignments before next time. One of them I haven't talked about. It's just an introduction to graphing. Okay. I can't imagine that you don't have a basic understanding of graphing if you've had some algebra. Okay. And it's at that level. Some of the questions might be a little more challenging. We'll see how you do on them and see how much I need to talk about it next time. That'll be due the day before class, I think. Okay, so have a good weekend. Let me know if you have questions.